Welcome to Sorcery. I'm your host, Molly O'Shea. Today, we have Sam D'Amico, founder of Impulse Labs. Impulse Labs is accelerating home electrification, starting with next-gen appliances. They've created one of the highest quality battery-integrated induction stoves with unbelievable power, efficiency, and precision. They last raised a $20 million Series A by Josh Wolf of Lux Capital in 2022. And more interestingly, they're also secretly known for their mission to be the Trojan horse for decentralized battery-powered homes. Really interesting. Special thank you to Min Kim of Lighthouse for the intro and Anna Sophia Lesiv from Contrary Research for help with researching questions. This is a really fun conversation, and we even talk about pancakes. I hope you enjoy. Hey, Sam. Thanks for coming on.
Thanks for hosting.
Well, I've heard a lot about you, and thanks again to Min Kim for the intro. From my research and from people I've talked to, it sounds like you're building the Trojan horse for battery-powered homes. I'd love to start there and get into what are you building and what is your big vision with Impulse Labs?
Yeah, so kind of starting from the beginning because, and not rebutting any accusations of people calling me stove guy on Twitter, we've built the world's best stove. And it's 3 times more powerful per heating element and more precise than any other stove. And we enable that by embedding a lithium iron phosphate battery into the stove itself. So it's powered by a battery internally. That's all cool. And I'm really, really, really excited about what we're going to be able to, give customers with this awesome product. But once we sell these to a bunch of people, we've then basically backdoored ourselves as the key storage power broker on the electric grid, because we'll have batteries in everyone's house. And so that kind of turns this sort of appliance company idea of hey, maybe you can build Tesla for appliances into a much more expansive energy company story.
To go even further back, how did this start? So when were you founded and how did you get the idea?
I was thinking in this space probably 2018, 2019 timeframe. The initial thing was actually, I think the initial thing that caused me to order some stuff online for prototyping was I wanted to build a overpowered pizza oven that could cook Neapolitan style pizza in the correct time, 90 seconds or whatever. And so was realized that that was not something you could do from just a normal plug. For reference, the standard US electrical plug gives you about 1500 watts of power, which is yes, it'll run a toaster or a blender at okay power, but it's not something that's going to make a pizza in 90 seconds or something like that. You need substantially more power. And then I kind of went down the path of looking at batteries and being hey, so how much energy and how much power can you get out of kind of the latest and greatest batteries that you could buy today? Realized it was more than adequate, and kind of annoyed the crap out of a lot of my friends talking about this and other ideas and things you could do. So I kind of started from the product first. I was okay, if you embed a battery in an appliance, you could make it more powerful for the first time. And this was also just as a reference point for where the market was. There were a number of, I think at that point, mostly fledgling, but some of them were more mature, smart oven companies on the market. And a number of them had pretty cool tech, but the idea was really driven by, could you put a smartphone chip in an appliance and then suddenly you could do some smart stuff cook perfect chicken, the Costco rotisserie chicken would come out or something. It would be stuff like that, basically. And it was that was the key thing, but no one had an advantage that was oh, our product is just twice as powerful as everyone else's. And I realized that was something that was just missing in the space. And in some sense, a key fact that meant that if you're a new entrant to the space, you wouldn't necessarily be able to compete with the incumbents or someone who knows what they're doing around the kitchen. You wouldn't be able to compete with the incumbents because you weren't actually better on key performance characteristics of the product. And so that became kind of that was the big draw for me initially. And then the second piece, and this is where kind of the Trojan horse battery deployment story comes in, was I started looking at the size of the batteries for various kitchen appliances. And I realized very quickly that the battery was going to be a couple kilowatt hours at least. And so once you're kind of in that 2+ kilowatt hour zone, you're starting to be a decent chunk of a Tesla Powerwall. And so realize that this was actually a much bigger story where if we go and convince people to upgrade to the most awesome appliances available, we then deploy a non-trivial amount of battery storage in everyone's home. And that's when I basically started drafting a pitch deck for it was not named Impulse at the time in 2019 around this concept, basically.
Wow. So this was in the initial idea. This didn't evolve with it.
Yeah. I think the decision to do a stove as the first thing came a bit later, but the idea was basically the initial playbook and thinking around this was very clearly build the most awesome appliances and you Trojan horse batteries into everyone's home.
And this isn't your first rodeo in hardware. You worked at Oculus before, and you mentioned you've also been to China and understood their manufacturing. So based on your previous experience, could you just share how that gave you more insights into this?
I've been in consumer electronics since, I think, 2012. I started as an intern on the Google Glass team between my undergrad and master's program. And then ended up staying there after graduation. For a bit before joining Oculus, as they were getting acquired by Facebook. And I actually think the combination of seeing kind of Google X attempting to make a mini Apple internally around this product Glass, and then seeing Facebook essentially attempt to do the same with the Oculus acquisition was this very interesting 0-to-1 situation where you could actually see how you'd have to scale down a hardware operation from best in industry standards to something that could still ship best in industry products, but wasn't necessarily a very established company and the undisputed leader of the consumer electronics space. And so it was actually, in some sense, really illuminating to see kind of the full stack as it got booted up versus joining an already established organization in that sense. And this comes into my skill set was in grad school was I did a lot of software, even though I was an electrical engineering major. Ended up kind of getting misscoped when I joined Google as a camera hardware person, which sounds totally random and disconnected from stoves, but by virtue of having to do the camera module on Google Glass, so basically it's the same kind of camera as in your smartphone or whatever. By virtue of having to do that, it was actually a mini self-contained consumer electronics program in and of itself, because there's all these complicated details about that. And that has, in some sense, helped me understand how to run these programs with third-party manufacturers out in Asia, and then apply those lessons to increasingly more complex things as my career went on.
So interesting. And in terms of Impulse Labs, how much have you raised to date, and who gave you the initial check?
Yeah, so we've announced 2 funding rounds. The most recent one we've announced was in 2022, and that was led by Lux Capital and Josh Wolf.
We just had Grace on, so we love Lux.
Yeah, I saw that.
Yeah, she's awesome. She's so good. Okay, so we talked a little bit about your background. We talked about the general ideation and vision. Now that you mentioned your stove guy, I can't get that out of my head. I'd love to understand the landscape to which you're building on. What percentage of home energy usage is tied to appliances, and why stoves first?
Yeah, so this is going to sound like I'm not tackling the big problem. And so when you think about home energy use, the first thing you really need to think about is heating, ventilation, and cooling. So, and that's about 50% of American home energy use goes into that. So you think oh yeah, you should just figure out how to time shift power for HVAC or something like that. But it's no one really you don't if you could have a gas boiler in your house or a heat pump. They can be centralized, but the UI UX is still the thermostat. And that's why Nest went for that versus necessarily ripping up the entire home energy system. The desire to go for stoves is, and I would say this is kind of crazy, is the average US house uses something like 20 or 30 kilowatt hour, all electric house is about 20 to 30 kilowatt hours of energy a day. My understanding of, if you go look at the Energy Star standards for induction stoves, an induction stove on average uses in the 300 to 500 watt hours per day or something very limited like that. So it's 1% basically of home energy use goes to something like a stove. Appliances are about 15% if you like exclude HVAC and I think hot water. And then hot water by itself is also about 15%. But you could argue that a water heater is an appliance, right?
Between all the energy usage within the home, like how is that distributed across appliances, and if that's changed at all over time?
Yeah, I mean, it has because of AC and heat pumps. So the big story is like, and lighting as well. So lighting used to be a much more substantial fraction of your home electrical use. And in some sense, it was like, in many cases, it was the only use case for it. If you had like a wood stove or something like that. But yeah, the lighting, I mean, LEDs have essentially changed the game, right? Like it's like a factor of 10 in terms of energy usage reduction for LEDs versus incandescent light bulbs. Like I think like a 60 watt equivalent bulb uses like 7 watts or something like that. It's something on that level of craziness. But yeah, that's definitely changed. And then obviously no one had like, I don't know, 600 or 700 watt computers that were running all day, or game consoles, or things, like those start substantially adding up versus even like 15 years ago or something like that.
It is funny because I feel like there's like a meme that goes around of like, you'd think that like your parents telling you to turn off the lights is really why like it'll decrease your energy bill, but it's actually because you're cranking the AC. And so because of the LED lights, it's really dramatically brought down that cost. And then it's like, okay, so if that cost is brought down by LED lights, and that's been a pretty good innovation over time, yeah, how do we decrease the rest of the energy usage across all the other elements within the home? So it's interesting how you're going after this battery-powered solution. Diving into that further, so what is the exact technical breakdown of the product, and how do you access the battery energy?
Yeah, so I'll start with so I mentioned like stoves are like a very small fraction of home energy use, but they're the one where you actually care about the fuel source, because it's like the UI UX of a stove is a flame, right? And so you have to innovate there. You have to produce a product that people are willingly going to want to switch to, because that's the reason they actually still have a gas connection in their house. And once you're starting to pay the gas company, then then you might as well switch, because you're already paying the fixed costs associated with natural gas. Then you'll use gas for heating, you'll use gas for hot water, et cetera. And that's where they actually make all their money, or that's where they actually sell you all the gas, right? Because your stove's not actually using that much gas. And so focusing on the stove first, because this was like an energy story for the home that actually hasn't really seen a ton of innovation. And we could actually go and do a step function that's significantly improved step function over anyone else. The key thing to realize with stoves is if you switch from a gas stove to an electric stove, or like, let's mention you want to put an EV charger in your garage. A typical home in the United States has about 200 amps of like circuit capacity available. And a induction stove and a EV charger use about the same amount, like about 60 or 40 to 60, depending on model and configuration, various things like that. So you're looking at a very substantial power usage story, even though the energy usage is quite low for something like a stove. And this means that it has kind of a relatively outsized footprint in like your home energy story, despite the fact that it's used super, super intermittently. Like if you're using a stove like an hour a day max, and you're not even using it at full power within that hour, like you're getting pasta pot to boil, that would be close to full power on one burner. And then maybe you're like medium low on average over a cooking session, whether you're aware of that or not. And so that realization makes putting a battery in the stove make a ton of sense, because what you can do is you can basically trickle charge the battery whenever energy is cheap and clean. So like middle of the day in California, there's usually excess solar power that like would otherwise be like discarded effectively, that you can essentially receive and know pretty clearly that you're not going to be causing a fossil fuel turbine to spin up or something like that elsewhere in the state. Now, and then additionally, you likely pay a lower rate depending on your energy plan. And so you can trickle charge all day. And then when you go and cook, maybe you want to boil water for pasta. On a gas stove, that'll take like 7 minutes per liter. So like, let's say 10 minutes for like the 6 cups of water for like a box mac and cheese from Kraft or Annie's or whatever. In our case, we can do that in about a minute, because we can push order of magnitude 4 to 5 times more power into the pan than pretty much any other stove.
Okay.
Because the battery is right there, able to give us DC power straight to the coils.
And like just much more efficient. I've lived in many different houses. My mom has a love for historic homes, but she still upgrades it with like the nicest appliances. And one of our previous homes that we lived in, there was an older Viking stove in there, an oven, and I swear whenever that turned on, the whole house would heat up. And it wasn't just the food would take forever, and the whole house would be really hot, and we'd be like, so what's going on here? But are you seeing more efficiency with like the actual transfer of energy because of that? Because you're saying it takes so much less time to actually hit the coils and then boil the water. Like you're not going to heat up your whole house.
Yeah, so gas stoves uniquely have this problem because gas stoves essentially heat the air around the flame, and then that gets transferred into the pot. But then a lot of the air goes around the pot. Like the pot's it's not like sealed, right? And maybe you don't have like heat fins on the bottom of the pot to like best absorb the heat into the pot. So they do make special pots like that. So it's estimated around like 60% of the energy that comes out of your gas flame heats the room, not the pot.
Oh my God.
And meanwhile, induction is like 95% plus, depending on a bunch of different internal electrical details. But what you're doing is you're generating a switching magnetic field with a coil. The stove itself is cold, but then the pot essentially receives that energy and heats up directly. So the only thing that actually is being actively heated is the pot. And the only losses are kind of like a combination of internal electrical losses or like the pot then heating up like the glass it's sitting on the stove or things like that.
So if you touch it, will you get burnt?
So it depends. So the pot obviously will be hot, right? Yeah. But if I take the pot off, the glass will be typically colder than the pot. It may be still warm because the pot heated it, but it would be it would typically be cooler than the pot. And if you go and put if you put like a towel between the pot or between the stove and the pot, only the side of the towel that's touching the pot will get hot and the stove will be cool.
Yeah, how does that work?
There's a couple different ways to explain this. Essentially what's going on is inside the stove, there is you convert the DC from so the battery is basically, think of the battery like an electric vehicle battery or something like that. But basically it's like you convert the DC voltage of the battery to alternating current actually. So this switches it to about 25,000 times a second. So basically you get a very fast sine wave. And the frequency is actually chosen for a very hilarious reason. If you make it like lower than 24 kilohertz, you'd hear it, or like your pets might hear it, or your kids might hear it, or something like that. So you have to put it just outside the human hearing range, but low enough that it's still efficient.
Okay.
And so you generate that, and this is being generated with a big, basically electromagnet. So there's now this giant magnetic field that's like right where the kind of like where the coil is. Now, as soon as you put a pot that has iron in it, so a magnetic pot, you're now essentially absorbing the magnetic field with the cookware. And then there are losses inside the pot that then heat it up. So basically it's like you're essentially making a transformer, if you know what that is, where like you can convert one voltage to another. So like the big one on your pole outside your house converts the like higher voltage that's like running around the street to the 240 volts or 120 volts that goes into your house. Essentially you do that, then you short the output. And so that'll get hot. And that's how induction works effectively.
Hey, we'll get right back to the conversation after a word from our sponsor. Sorcery is brought to you by Archer. I'm genuinely amazed at what Archer has been able to accomplish. Archer's goal is to transform urban travel, replacing 60 to 90-minute car commutes with estimated 10 to 20-minute electric air taxi flights. They are safe, sustainable, low noise, and cost competitive with ground transportation. Archer's Midnight is a piloted 4-passenger aircraft designed to perform rapid back-to-back flights with minimal charge time between flights. Learn more about how Archer is set to open up a new world of opportunity for passengers by providing safe and efficient access to people, places, and events across the communities they live. Visit archer.com. How do you integrate these into the home? Like, I know my friends who have Tesla Powerwalls, they have to get special setups and that kind of thing. Is this the same thing?
No. So one thing that actually, I think this is part of the whole kind of Trojan horse play is an appliance installation. So a Tesla Powerwall installation costs about $6,000. And then so the Powerwall costs like $12,000, but installing it costs $6,000 because you essentially have to go to your main electrical panel and do all this hacking to make your house able to back up parts of the house with the Powerwall. Basically, there's all this huge mess there. In our case, we're not doing a whole home backup solution. We're just making a single appliance to start. So there's no tear up on that side of the house that you have to do. You just have to essentially plug or wire in the appliance, just like you would plug or wire in a normal appliance. So we can actually go through the normal appliance installation path, which happens every day in every community all over the world, basically.
Great. So constraints there.
And there's no constraints there. And then the other piece is a big story, which I mentioned earlier. Typical stoves use 60 amps or something like that. We can run on as little as at 240 volts. We can run on as little as a 120 volt outlet. So you can just plug this thing in with your normal AC power cable and get the same stove performance as someone who wired it in on 240 volts, for instance. You'll get a full-blown, full-performance stove no matter what your home electrical system has in your kitchen, basically.
And where does the battery sit? Is it just under the stove? Is it separate? Do you have to find special room for it? How does that work?
Yeah, so basically the way it works is, we're selling a cooktop. There's basically negative space inside the product that the battery inserts into, just it slides in effectively. We ship the product with 2 boxes, and you just get a battery in one box and a stove in the other, and you latch them together effectively, and then you do the installation. The only real change is that you need 2 people to lift the stove versus just 1, because it's a little heavier now.
Now that we've broken down the product and the vision and what you want to build, where does this sit at in terms of price point of existing appliances? Is the goal to get it down to a certain price, given batteries are typically expensive? How are you envisioning that, and where do you think the entry will be?
Yeah, so this is actually where our thinking on market positioning, just at the beginning, I want to kind of describe what we were planning on doing here. The goal from the beginning, and we have held to this hard and fast, is ship the absolutely best stove that exists. We want to make sure that this is, because the problem with this entire space is basically people don't trust new brands. People will think highly of brands that have been in their homes for decades or even a century or something like that. We need to beat that by basically just being the singular best. It's kind of very similar to Tesla being hey, we're coming out with plaid mode or something like that. We need to make sure that we exist at this different category, different tier, where there's a different set of capabilities that you can do, and making sure that that is offered to people in a non-inaccessible price, but still premium price, if that makes any sense. And so the first thing to kind of talk about is we are about 3 times more powerful than pretty much any other induction stove for heating a standard size pot. If you want to boil water, again, we can boil a liter in under 40 seconds. My Viking gas stove that I had before is 7 minutes at doing the same thing. So it's kind of this just insane capability bump where we can be actually, a watch pot boils now. We've changed that term of phrase. And so that's the first piece. And then the second piece is, so crazy high power. The second piece is try to make sure that we win on control and precision as well. So we want to be the most powerful and precise stove ever made. And the precision angle is something that people do not understand, but they actually do this every day, which is if they bake. An oven has exact temperature settings. You don't set your oven to medium, you set your oven to 350. And so making sure that we can actually carry that to a stove with any pan was a insane engineering challenge. But the results mean that we can do things that no other stove can do like you can basically fry an egg in a stainless steel pan and guarantee it will never stick every single time. You can temper chocolate on the stove by setting an exact temperature and getting the crystal structure of the chocolate perfect. And then you can do this other thing that I like to do when people come visit the office. And if anyone listening is hungry in San Francisco, please hit me up. Basically, I can sous vide a steak just in a pot by setting the pot to 140 degrees or something like that. It will get the steak up to like mid 130s all the way through without a bag, no plastics, no agitator, nothing like that, no water. You just put it in the pot with the lid on and it cooks. And then I spend maybe 3 minutes searing both sides and it comes out totally perfect. The idea is basically just to show that there's just this family of capabilities that just doesn't exist, and that every stove should be one that has precision temperature and this much power. And that we're now the vanguard of this new category of appliances, basically across the spectrum of devices beyond just a stove. So that's kind of the positioning, right? So it's like basically make sure that we offer capabilities that do not exist anywhere else. The second thing is, and it's just going to keep sounding like Tesla, there is a massive government incentive package available for people replacing their gas stoves with electric stoves. It's very similar to how there are rebates and tax credits available for electric vehicles. But because this thing has a battery, and because that battery is 3 kilowatt hours, we get a 30% tax credit on the product. So we can offer the product at a premium price point, which is comp very fairly to like the higher end of Bosch's lineup. I think that Thermador or Gaggenau, those sort of brands. But then there's a 30% markdown based on, thanks to federal tax incentives. That means that we're actually much closer to, say, where like Samsung and LG and some of these other kind of more high volume brands sit for their higher end products. And the thinking is basically we can kind of operate there because that's where like a majority of the margin is in the space. And it's a good place to start because it's both like accessible, but also premium. And then additionally to that, there are income-based, like up to 150% area median income. You get like an $840 rebate on top of it. And so all of these stack. So in some sense, it's like the federal government is massively subsidizing the product while letting us position it as like a unabashedly premium thing.
Right. What about pancakes?
The first one comes out perfect every single time.
Does it?
Yes.
What is the science behind pancakes always sucking on the first pancake?
It's because
why does that happen?
That's a good question. There's actually basically I think a family of things revolving around I am not good at cooking is actually that you are not good at controlling the temperature of the pan. And so, and I'm not accusing you of being bad at cooking. I'm just saying that generally. The reason the first pancake's bad is maybe one reason is like maybe you don't have the oil spread around the pan properly, and that's one legitimate thing. But the second and most probable case of failure is you're using like a cast iron pan or a cast iron griddle. It is not yet up to temperature because you have to wait for the heat to kind of like spread out, especially with the cast iron ones. It takes a very long time to do that. And if it's not the right temperature, you end up in this situation where it will most likely undercook and stay stuck because like it won't dry out the bottom of the pancake basically enough for it to naturally de-stick. And then there's another situation where if you're like not, maybe you're using like if you're using a stainless steel pan, you might have the opposite problem where it gets so hot that it burns and then it sticks. And so there's this interesting situation where like the entire existence of nonstick pans is driven by the fact that people, like basically stoves have like incomprehensible 0 through 10 settings versus an exact temperature.
You know, I think it was really revolutionary when they put a popcorn button on a microwave. I think you're going to need to put a pancake button on the stove.
We don't really, because it's just like we just set it to fry or something. You set it to like low fry or something, and but we're working on. That's actually a really good question. It's like, so it's a very good question because this is something that like we're shipping the product end of this year. I am definitely a tech guy, and so I put a screen on it And it was kind of like, I was kind of like pedantic about, we need the screen to be like at least this big for various reasons. I'm making sure that when we're trying to adjust user behavior to something that's kind of never been done well before, making sure we can iterate on the UI UX and like didn't have to lock that when we didn't actually have a working unit was a big deal. So like we've actually iterated a bunch on making sure that we offer both the power and the precision control in a way that's not like looking like you're configuring an alien spaceship. And that requires us to be able to iterate on the real hardware. So like making sure that we have a screen there and it also like communicates with like metaphor words like, hey, this is like a good temperature for pancakes, for instance. And also we'll have specific modes just like other kind of smart devices do because we've got the capability of expanding the UI and stuff like that. But that said, like I want to be very clear on the UI, like the user experience is you walk up to this thing and you turn the knob and the stove gets hot. And that is not something we wanted to change or cause like put roadblocks in the way before someone can use the product.
I like that. That's really cool. And I like the screen. We like screens. Screens are great. To take a step back, what's your vision for Impulse Labs in 20 years if everything goes right? How does this all connect and how will our homes operate?
Yeah, so I mean, I think I told this to some people, but I think there's an opportunity. So I think it's very hard to start a car company, for instance. I think it's one of the hardest businesses to start. But it was sort of this crazy idea of like, could you start a Tesla without making cars or running your own factory? But you could build just as an expansive vision of electrification, of like deploying distributed energy storage all across the grid at various different sizes and shapes, and like key advances to how you live your life, how you interact in your day, like, you know, really advanced, like meaningful chunks of time. People are cooking, people are driving, those sort of things. That's where I want to see this end up. And I think that's like the company is built for the vision of that happening. And we've made sure that like the first product actually has the entire kind of, let's call it near to medium term vision encapsulated in it. It's got like, it is a product that pushes us forward from a like capability standpoint in the kitchen, like a couple generations of technologies, hopefully. But also it's got the full battery integrated in the product. It's got an inverter. You can deploy these, and then we've now deployed meaningful energy storage that can work with the grid to charge and discharge, even if you're not cooking, which is a huge deal. And all of those technologies we can then take and put into other products in the future because they will be certified, compliant per all the safety standards that exist in industry. And we can actually go and take those to other products and quickly ship an entire family of devices. Maybe they're not stoves or ovens, but like you can think of other appliances as well, hot water, laundry, like those sort of things start to add up. At that point, there's actually this situation where if you have like 3 or 4 appliances per home, you've now deployed about a Powerwall per house. And so once you have which is like, let's say 12 kilowatt hours or something like that, that is like half the energy use of a typical American home that's all electric. And you could then shift all of that home's consumption to like solar and wind, basically. And this is a huge deal. The other thing that's happening is there's all of these complaints about enough investment in transmission infrastructure around the grid. So it's like basically the wires are too thin for the new energy usage we're going to be doing. And I think kind of going back to some of the earlier stuff about like, yes, things have gotten more efficient, but I think another exciting thing in the future is that we can let people use more energy. Like there's going to be more, we can do more and have a higher power future versus a kind of degrowth future. And the thinking is you can actually solve a lot of these distribution problems with batteries because you don't have to transmit the energy right when it needs to be used. You can transmit the energy beforehand effectively when the wires are not at peak utilization, for instance. And so that's a giant deal which is why battery storage matters, not just for like making solar and wind energy last the entire day, but it's also so that we don't necessarily have to go and essentially double the thickness of all the wires on the grid to support like electric vehicles, electric appliances, et cetera.
So your part in the grid is somewhat to decentralize it and give more power, quote unquote, like actually power back to each home. And so each home can be a little bit more self-sufficient.
Yeah, I think I think that the big deal here is like homes now can draw, if everything has a battery, and this is kind of like the eventual vision is everything will have a battery because batteries will be basically cheap or free effectively. If everything has a battery, and they can choose when to charge. And I'm sure you've seen like the iPhone pop up where it's like your iPhone can choose when to charge when like for various grid optimization purposes. Every device will have technology like that, and every device will have a battery. And suddenly what that means is you can solve all these kind of like bottlenecks of like, maybe there's not enough, like maybe the transformer on your street won't support you and your neighbors charging your car at the same time. But if there's enough battery storage distributed in all the homes, this doesn't matter. That transformer won't be overloaded effectively. And then that means the utility doesn't have to go spend on a bigger box on the pole, basically. And so this ends up actually it distributes the grid and distributes the batteries all over, which makes everything more reliable, but it also is an alternative to us kind of like having to spend this ridiculous amount of money on not optimizing, but basically on building a grid that is scaled for like every light being on at the same time, basically.
Hypothetically, if there is some sort of widespread power knockout, maybe it's from a heat wave, maybe it's from a large solar flare. Who knows? Would this then save you from that and you would just be able to maintain your own, like AC and whatever essentials you might need during that emergency? Or how does that work? Does this help replace those generators and that kind of thing for energy in emergencies?
Yeah. So, I mean, if you've distributed, let's look at the kind of the big vision. If you distributed like over 10 kilowatt hours per home in the US, like you can ride out pretty major like outages. And the big story with like a heat wave is heat waves are really bad for the grid because essentially everyone's turning their AC on full blast all the time. But like the sun does set, right? And then they won't need to keep their AC on as high. So as long as you can last that 4 hours or something like that in the middle of the day, which is 10 kilowatt hours of batteries is more than enough to spread that out like way later in the day, you can actually greatly reduce the threat to the grid, like aka some mass blackout or rolling blackout type situation, just by having the storage like cooperating with the grid. Now, if there is an outage, additionally, like the house has the battery storage and can self-power, right? So there's a resiliency angle both when the grid is up and when the grid is down. And then there's like a number of other kind of like black swan event, like big solar flare, nuclear war, these sort of things like that. Generally moving the control, sensing, and like energy storage out to the edges means that any sort of centralized disaster doesn't do as much damage, right? And so there's a second like awesome characteristic about this where basically we've taken like a power plant and we've cut it into little tiny pieces, and then we put all those pieces in every home in the United States. And that means that now you can't like blow up that one power plant. So, like there's no one power plant to blow up. It's kind of more like, it looks more like the internet than a single mainframe or something.
Okay. So how do we get more people to adopt it? How are you going to be selling these? Are they going to go straight to Michelin chefs first, or are they going to go to some luxury home designers, real estate developers? I don't know. How is this going to work?
So there's an all of the above kind of thing that we're taking here. The Michelin-star chef thing is actually a really funny note. And I don't know when this podcast is getting published, but stay tuned for announcements there. We're very excited about some future partnerships in that direction. And a lot of that's driven by straight up because of the temperature sensing capability. Like the battery is like a bonus in some sense from like versus the product bona fides of getting this sort of awesome stove performance into, even regular people's hands. And so the thinking is basically, like we're going to excite people about the capabilities of this product, make it like, and make sure that we make the case that this is a unique kind of N of one device. Like there's nothing else that has the power and precision of this product, period, on the market. I have a pretty good understanding of appliance roadmaps. I've talked to leading folks at major appliance companies, and I don't think that there's going to be anything that comes close to this for many years effectively. And so the thinking is, you get people who want basically the best stove to go buy it. They could be Michelin-star chefs. They could be my mom. Like, it doesn't really, it doesn't really matter who those people are. That's kind of your first vanguard class of people. Now, additionally, like, we need to make sure that this is something that people can access and like see and touch. Like, we've got some really cool tech that's hard to describe in a podcast. Like, our knobs are awesome. You can remove them to clean. Like, they have a really good tactile click action that feels really fantastic. But like, you need to be able to check that out and find a way to see impulse in your community, basically. So that's another piece of like the distribution puzzle. And then lastly, yeah, like we've had very serious conversations with a number of folks, kind of both in like the multifamily developer community, but also like other folks that have a stake and an interest in electrification. And there's a huge amount of demand structurally to like decarbonize buildings and do it in a kind of like awesome tech forward way where they can use it to like kind of market the building later or market the project. And so we're also having those conversations. And like, obviously, if you're listening and curious about that, feel free to reach out to me.
Love that. Why has Restoration Hardware not gone down this route yet? How come they're not
the
doing
problem
appliances?
basically is I would say that there's a couple things. So batteries were not, and I should just say this more generally. Why is this product not? Why is like a stove with a battery a 2024 thing and not a 2014 thing? Mm-hmm. And so there's kind of this other angle, which is like batteries were not cheap enough until cars made them cheap by necessity. And so essentially the electric vehicle revolution has enabled this to happen, because now you can put like the raw battery cells that go into our product, I think order of magnitude are $300 now. And so it ends up like, that means that now you can ship a premium stove that doesn't cost like 12 grand or something insane. Because the actual battery cell costs only now are there. That's one piece. That's one piece of it. But the second piece is like, I think making a compelling product in this space that actually stands out requires the almost like accidental invention of this new temperature control scheme that we came up with for the stove. And so it's like, and RH makes awesome stuff. I have some of their stuff and I like it. And also, if anyone from RH wants to talk to me, I'm down to talk to them about any collaborations. The bigger point about that is like, they're not necessarily technologists who are going to realize that like, hey, if we can innovate on these three kind of different sounding things, we can produce a product like Impulse.
I mean, I think that's a really good segue to go deeper into the battery section. I know I dove into it a little bit before, but it's quite the interesting topic, as energy is really top of mind, whether it's with the different EVs and like the charts coming out on that. But before we even go into that, I'd just love to understand more on how much more work is needed to be done on new battery chemistries, energy density, and costs, and all of these things to come down, like you just mentioned.
Yeah, so I think there's been a bunch of, I think, noise in the space. I would describe it as noise, because in some sense, if you're only casually following along with kind of the electrification of everything thing that's happening right now, you might be like, okay, you're going to hear a bunch of different things about China, about the US, about Tesla, about like EVs not necessarily penciling in terms of cost, about Ford losing money on the F-150 Lightning. Like, you're going to hear all sorts of random news. But to kind of bring this to some clarity, I'll describe kind of sequentially what happened and where the future is going to land. So Tesla, in basically with the Roadster, cracked the code that you could take the batteries that were in standard high volume use for pretty much every laptop and reconfigure those cells into a reliable battery pack that was like, it actually worked for a vehicle and was safe, and you could, pass crash testing and various things like that. This was a giant singular advance that enabled the electric vehicle revolution to take off. And that pack architecture lived from the Tesla Roadster and then they've iterated multiple times from like Roadster to Model S to Model 3, et cetera. And that's using what's called lithium cobalt oxide cells. So basically they'll use like lithium, aluminum, manganese, and cobalt chemistry. And this is typically referred to as lithium ion batteries. It's also the same chemistry roughly. That's what's in your phone and laptop. And so that's where you've often seen like stories about battery fires, various other stuff like that. Tesla's key innovations were making a large pack with tons of those cells safe and high power and awesome and all these, and cheap as well. Meanwhile, in China, a second thing was happening. So a lot of key IP got obtained by Chinese companies for a different chemistry, lithium iron phosphate. And this was first pioneered for the Fisker cars in like the beginning of the 2010s in like a hybrid vehicle context. It's a lower energy density chemistry. And the idea is that the cells are cheaper and like more durable and also way less prone to fire risk. A number of advancements happened in the Chinese lithium iron phosphate battery space, but they culminated in basically these Chinese companies being able to produce very large battery cells, like the width of a vehicle for a single cell. And this then changed the game because Tesla had essentially figured out how to take tiny, I'm going to use a Red Bull can as an example, like cylindrical batteries that are maybe like half the size of this, and assembling a big pack out of those. Now, suddenly, when you've got a battery that's like the width of a car or half the width of a car, and you just have to put a bunch of them in a box, and they're all rectangular and really easy to assemble, it makes the manufacturing challenge a lot easier and a lot more scalable and a lot more affordable. And this is kind of called like cell to pack technology, among other terms. That has allowed these Chinese battery pack manufacturers and electric vehicle manufacturers to push the price down massively. And now we're looking at like cell costs of like $50 a kilowatt hour. For reference, like a typical Tesla Model 3 pack is like 60 kilowatt hours or something like that. So it's like you end up with battery packs that could be like, they don't like $3,000 of battery cells go into one of these cars now, which is ridiculously cheap and now means that you can beat the price of combustion vehicles for the first time with electric vehicles. So this has happened, and now we're kind of in this sort of like quote unquote China shock situation where a number of very, very big, very, very competent companies like CATL, BYD, et cetera, make the actual packs for the lower end of Tesla's product line now. So if you get a low end Model 3, you're actually getting a CATL or BYD pack. You're not getting the Tesla design pack. But those cells are slightly lower energy density, but they've been creeping up in capability. So now we're seeing a situation where there's actually kind of two different tech trees that are in competition now. And we're seeing now new investment to kind of like straighten all this out in the West in response to China's success. That was a long answer. I'm sorry, but I hope that made some sense.
Yeah, so it sounds like China has taken market share of batteries. They've figured out how to manufacture them better and more efficient and more optimized. And the US was kind of left in the dust, even though they first kind of figured out how.
And the US still has the market leader, right? Like that's the other big thing. Like Tesla is still arguably the market leader, but the supply chain is not available for everyone else, right?
Interesting. So their supply chain comes from China.
They are doing both. So Tesla is like now big enough that they have vertical integration where they do things themselves internally. Like if you buy a Cybertruck, the battery pack gets made in Texas. If you buy a Tesla Model 3, the battery pack gets made in Nevada, near Reno. But then if you buy a low end Model 3, like the $30,000 one or whatever, that pack gets made in China.
And in terms of the supply chain, going to the mining standpoint, like where are they mining all of this lithium?
Yeah, so I think it's they're all over the world. There's also like new discoveries in the United States. Part of this is due to the fact that like we're now realizing we have to do this stuff. So like you can actually look at lithium prices. I think lithium carbonate is the like mineral, and the laws of supply and demand are causing new mines to open everywhere. I think Bolivia is kind of the most famous for having lots of lithium. But there's all this talk of like the Salton Sea, like you've been to Coachella, like that whole kind of abandoned town over there. Like you can drill like you drill for oil and extract the water and or pass water through there and get lithium salts out of the ground. And so basically what's going to be happening is there's going to be a new set of kind of like mining, resource extraction, et cetera, big players, kind of like how we had with oil and gas industry. The difference is we can recycle all of this, and we do recycle all of this. So it's like batteries are not like consumed like gases. And so the like visible footprint of this, I believe, will be substantially lower than like the fossil fuel version, just because of the fact that batteries last the life of the vehicle typically.
Okay, well, I guess that's bad news for anybody who likes to go to Coachella, because that's not going to exist. But
The Palm Springs will be fine. The Polo Grounds will be fine. It's just that there may be a booming mining town within short driving distance.
Maybe that'll make Coachella even better because they'll have extra money. I don't know.
It's possible.
Anyways,
We'll see.
Anyways, I wanted to really get to a question, and then we're going to wrap up. But do you imagine, given these different elements that we just mentioned, like, do you imagine America becoming a strong competitor for creating and actually manufacturing batteries? Like,
yeah, so we're going to have to be. And ironically, China is going to help us here, and is in process of helping us here. And so I think that's also a narrative violation. Like, the most probable biggest battery factory news in the US is Goshen, which is anglicized form of Guoshan, the Chinese large battery cell and pack manufacturer, is opening a cell and pack line, I believe targeting automotive and stationary storage in Illinois. They did a big buzzy announcement with the governor and stuff like that. I think like either earlier this year, like maybe it was late last year or early this year. And BYD has a facility that builds like all the transit buses down in LA. There is Chinese manufacturing expertise moving to the United States. I've also heard stories of like Tesla buying CATL's cell and pack equipment and relocating it to the US for the same reason. And a lot of this is driven by the tariffs on battery cells and packs getting pushed up a little bit, and that making sure that like essentially Tesla's trick of getting these Chinese packs and putting them in cars in the US is going to run into the issue of they're going to want to source the packs locally. But that doesn't necessarily mean that Chinese firms are going to get cut out. They just may relocate their lines to the United States. So that's the first thing that's going on. And then the second thing that's going on is like, I think China understood this correctly, is the future, the kind of all this new energy stuff is like clearly the future and requires a little bit of a different industrial supply chain that looks more like, say, consumer electronics, which they were good at, obviously, versus kind of the legacy pre-World War II era industries in some sense. And so betting all of their chips on black with that was a incredibly good geopolitical decision. The US obviously will need to keep up with this, right? Like, this is going to be a big deal. We're already starting to see pretty substantial like trade barriers go up around Chinese electric vehicles because of this fact. Like, China can offer, like, you can get a Tesla Model 3 equivalent vehicle for like $25K delivered, and the vehicle quality is fantastic today. And so we need to wake up to the fact that they are not like America's cheap factory. They are like really, really, really good at this stuff, and have incubated equivalent of multiple Tesla-like companies internally that we're going to have to contend with, and like realize that like we need to do the same, basically.
Exciting. It sounds like we have a new economy forming.
I mean, and I like this because it's good for me, right? So we can, and I don't think that people have realized that like people anchor on cars and vehicles and military stuff and things like that. But it's like, you use your appliances every day. They're in every home in America. And it's a giant, giant, giant opportunity to deploy a lot of batteries.
And like every month or so, we're hit with a different kind of like more personal threat of whatever weather condition is going to happen. And, you know, you're forced and I hate to make that like a climate thing, but it's true. Like, I don't know, I've been through a couple of different storms in my day, and it sucks when you're out of power for like a week or 2 weeks or something like that and you can't get it. But I think it's really exciting how you're decentralizing that and you're creating more self-sufficiency for different Americans and more resiliency on top of a really cool product.
Yeah, and the goal here is like the entry point, and this entire podcast we talked about a huge number of things, but the goal here is the entry point is just to ship the most powerful and precise stove ever made, and make sure that we lead the industry in that. And then there will be understanding of the big picture as kind of people get their own chance to peel the onion, right?
It's a 2-for-1. It's great. Well, Sam, just as we wrap up, I like to end on a positive note, as if this wasn't positive already. This has been a really fun conversation. What are you looking forward to most in the next 12 months?
I think it's shipping the product to real people at scale is going to be the most exciting thing ever. Like, I think we've built a really killer supply chain with a set of really awesome partners, and it's going to be awesome to kind of like prove that the whole machine that builds the machine works. That's going to be a huge deal. I've also think that as part of the product being released and being out and about in the world, like I will have so many more tools to use to sell the bigger vision to people, because like the kernel that enables it will be out, right? Like, and I think that's the big thing that is incredibly exciting about what we're doing here.
Amazing. Well, thank you so much, Sam. It was a pleasure.
Thanks for hosting.